Welcome to the Crazy Hat Chemist. So another video here on chemical equilibrium. It's number 2. Bam! So today we're talking about the equilibrium constant, or the Keq. Okay? For any chemical reaction, and I'm going to give you this chemical reaction. So the lowercase letters are the stoichiometric coefficients. The uppercase or capital letters are formulas. And then in the parentheses are the states of matter. So Ta, solid, plus Ub, aqueous, plus Vc, aqueous, plus Wd, gas. And then you see that double-headed arrow, that lets you know that it's an equilibrium reaction. Those are the reactants. The products are Xe, aqueous, plus Yf, liquid, plus Zg, aqueous. And those are the products. That little double-headed arrow there lets you know, again, that it's an equilibrium reaction because you can approach it from either the reactant side or the product side. It's dynamic, it's shifting, it's constantly changing. Okay? The equilibrium constant expression, the Keq, is the product or products divided by the reactant or the reactants using the balanced stoichiometric coefficients as exponents. So I'm going to repeat that again because this is very important. We're going to be using this not just for this unit, but many others. The equilibrium constant expression, that is the Keq, is the products divided by the reactants using the stoichiometric coefficients as exponents. Okay, so we're going to figure out what that means here. Okay. Furthermore, to add to this, solids and liquids are not incorporated into Keq expressions. And the reason that is because they do not affect the equilibrium value itself, the Keq value. Okay, so solids or liquids do not affect the equilibrium. Okay, the value, the numeric value, or they do not affect the shift or the change. So we're going to write the equilibrium constant, the Keq, for that above reaction. But before we need to do that, we're going to take a look at that previous sentence here, and that solids and liquids are not incorporated into Keq expressions of any kind. So what we're going to do is we're going to find any solids or liquids and we're going to cross them out. The Ta is a solid, so I'm going to cross that out. I also have the Yf, that's a liquid. So the compound A and the compound F, or maybe those are elements, are solids and liquids, and those are not included in Keq expressions. So from hence point forward, I'm not going to include those in the Keq expression, but I'm going to have products over reactants with the stoichiometric coefficients as exponents, and that's what I'm going to have. So my products are on the right-hand side, my reactants are on the left-hand side. Okay, so here's my Keq expression. So I've got brackets, and it's essential that you have brackets. It's a Keq expression. We'll talk about if you don't have brackets later on, but for right now, everything is going to be in brackets. So I got brackets and the E to the power of X, G to the power of Z. Okay, so you should see that aqueous things are incorporated into Keq expressions. Those are the products which are in the numerator, and then divided by the reactants, which are going to be in the denominator. And the reactants are a B to the U power, C to the V power, and D to the W power. Notice that aqueous things are included in Keq expressions, gases are included in Keq expressions, but not solids or liquids. Okay, and so a little bit more further about this Keq. Okay, Keq is temperature dependent. So almost every single time we need to include the temperature in with the Keq. The Keq is a value that has no units to it. Okay, when the Keq is less than 1, then the system is reactant favored. So if the Keq is less than 1, then it is reactant favored. Okay, that's going to be very important. When the Keq is greater than 1, then the system is product favored. Okay, so that's towards the products. When the Keq is equal to 1, the system is at equilibrium. Okay, so these are the states that we must, these are the parts that we must follow in order to come up with the Keq expression. Remember, products over reactants with the stoichiometric coefficients as exponents, solids and liquids are not included in any Keq expression. Okay, I'm the Crazy Hat Chemist, and I got one of my favorite hats here for you today. It's called a cork hat. And the beautiful thing about a cork hat from Australia is that you can just kind of move your head just slightly, and these little wooden corks or these pieces of wood move around, and that keeps all the bugs, mosquitoes, far away from you so you don't have to wave your hands all the time. Okay? It might even work with pesky students. I really don't know. Haven't tried that out. If you like that video, give me a thumbs up, subscribe to my YouTube channel, and find my website online. There's going to be some merchandise there pretty soon. All right, I'll talk to you later. Bye for now.